Okay, so you don't miss my melodious voice today. How many people are missing? Here are the notes written by another teacher yet again. Feel free to pause the video if I'm going too slow. And if I have to explain this, where were you in grade school? Did I say good afternoon? But you went too fast. That's only 30 seconds. Take the movie backwards then and look at all those things. Why am I talking this way? I don't know. All right, but remember we talked about skewed? Okay, so symmetry, we'd have a symmetric scenario. Um, if Please stop doing that. I can't concentrate. If you have a symmetric scenario, the mean equals the median. Okay, and then I jack this up. I'll admit it. I'm not perfect. Believe me. Oh, if you only knew some of the things. But if it's skewed, now when I first taught this to me, I felt like it was skewed right. So that's what I said in back in chapter 10 when we started looking at these bar graphs. Then I caught it the next day. Okay. And actually, the definition of why this is skewed left is because, the median is over here and the average of the data is over here. So the mean is left of the median. So that's where the word skewed, that's in reference to that relationship. All right. And then the median's over here, and the mean of this data would be over here. So the mean is bigger than the median. So it's skewed right. The mean is skewed right, the average. So I don't know. Um, me doing this for the first time, the other teacher last year did 10 first, then 9, and then that's where I lost that, definition. Wasn't prepared enough, and I'll admit that. Made that mistake back in the day. There you go. You can cut that and share that with your parents. See, my teacher is bad. All right. All right, now weighted mean. Mean is average. Weighted, in this scenario, I'm showing the definition so you don't get overloaded with this formula AX scenario that's written here. Let's actually look at this to compare what it means to be a weighted mean. Grade point average. I have two A's. Well, an A is 4 on your scale for an unweighted, GPA. A B is worth 3, and a C is worth 2. All right, so the average ends up being your GPA, where you have to take two A's and multiply it by its weight, its value. Don't get confused with what's down here. This is still divided by the amount of grades you have total. 2 grades, 2 A's, 2 B's, and 3 C's total. There's 7 total grades here. All right. But an A is worth 4 points, so there's 2 4s. B is worth 3, and a C is worth 2. So there's a weighted mean in a way. Not a weighted grade point average, a regular grade point average, but the idea of a weighted mean. The regular algebra 2ers throughout the day have said that they actually did see this or have done this before. This is a way of organizing data into quartiles. Quartiles means quarters. What percent does that represent then? 25. It's very simple. Okay, so range is obviously highest minus lowest. Don't confuse that with spread, which just means from 3 to 22 is the spread. This isn't a minus sign here that I'm identifying. And I think some people messed that up back in the day, but not a big deal. So the range is the difference between the highest and lowest value. Some set of data had 3, blank, 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 22. Okay? So that's where those random numbers are coming from. And then the ability to put these in a quartile scenario. 25, 50, 75, 100% of the data put in quartiles. Okay, so go up here for those that are taking notes verbatim. You might get in your book a smattering of data that's all over the place. 27, 33, 1, 7, 25, 93, 83, hike. So your step 1 is to put it in order, very simple. Step 2 is to find the median. Very simple. The median cuts the data at least in half, right? At least, exactly in half. I don't know what I'm talking about. If you have an even amount of numbers as you're writing this down, let's say you had 20 numbers. How do you find the median? Which two numbers do you have to grab? To give you a hint. Which ones? There's the first, second, third, all the way up to the 20th. Which two numbers? 10th and that's what I'm getting at, 11th. And then what do you do with those two numbers? Add them and divide by 2. Now you have to understand something next. This is what these stars represent, okay? I gave you an example of 20 numbers. Okay, that is a perfect 10 and 10, isn't it? 10 on the first half, 10 on the second. So if your data is even, which is this situation, then you go to the next step, which what this is you take those first 10 numbers and just find the median of that. By the way, if I have the first 10 numbers, how do I find the median of the first 10 numbers? What two numbers do I select? Because 10 numbers, again, that's even. So I select the what? Fifth and the sixth number and divide by 2. So the median of the first half will be the first quarter separation, right? All right, but say you had, in my example that we'll show you, and I'll try to explain this again, but this is what the star is all about. If the numbers are odd, well, let's go ahead and talk about that. Say you have 7 numbers. What number is in the middle? The fourth. So how do I find the median of the first 3? Well, you ignore the fourth. That's what it means about crossing off the fourth, and you just find the median of the first 3 numbers. And then you find the median of the second 3 numbers to get the what's called quartile 3, which represents 75% of your data. So I know in Word sometimes it's a little much. Why this star and why do we ignore this number? Well, it's because if I had 7 numbers, the fourth number is the middle and should not be considered at all when I'm finding the middle of the first 3 and the second 3 after those. But if I have an even amount of numbers, say I have 8 numbers, I have 4 and 4. I need to find the median of the first 4 and the median of the second 4. I can include them all. All right, and then what you do after that, the median of the first half is the Q1. The median of the second half of the data is the quartile 3, which represents the 75th percentile because you're up to 75% of the numbers covered. So basically what you're doing is just grouping the numbers in the first 25% of them, the second 25, the third 25, and the fourth. And then you make what's called a box and whisker plot out of this. You call it a box plot, but I call it a box with whiskers. All right, so what's the first value? The minimum value. What's the middle value? The medium. What's the last value? The median. I don't know what I just said there. I think I said medium. And then the last number is the highest number in the list. And then Q1 numbers and Q3 numbers are, separating the first 25% from the next 25%, from 50th to 75, 75 to 100% of the data. And then this is, we'll show you what a box and whisker plot looks like next when we actually do this example. Okay, so here we go. It's already done, but let's focus on what we have. We have a book question where the numbers are 63, 58, 72, 84, blah, 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 blah. Very first thing you have to do is order the data. Put it in order from least to greatest. Now, looking at this example, and again, don't just be a rote memorizer or just rote taking the notes. Just look at it. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 numbers. So this is what I was trying to talk about, those that were in tune. Hey, if I have 20 numbers, what's the median? Well, it's the average of the 10th and 11th. Hey, if I have, I don't know what else I gave as an example, 7 numbers, the fourth number. Well, this is 17 numbers, so the 9th number is the median. And that's what it is, the median. Okay, we got 63 happening 3 times. That apparently is the mode because that rhymes with most. Get somebody mad. All right, now, you don't include this number because half the list happens before this number and half happens after, right? So this is where we exclude this number. That's why it's crossed off to find the median of the previous 8 numbers. There's 8 here and 8 here. So when you have an odd amount of numbers, to find Q1 and Q3, you ignore the middle number, right? And then you find the median of the first 8 numbers. Unfortunately, that's the average of the fourth and the fifth. Then you find the median of the last 8 numbers, okay, because that's exactly half. If this was gone, and this was your list, how many numbers do I have now? Ah! That's in case you were sleeping at home. I had to make sure a couple students weren't sleeping in my 6th hour. Okay, so how many numbers do I have now? Just answer the question. Well, there were 17 and I subtracted one. There's 16. Okay, so what's the median? How do I find the median? I got to do what? Find the average of these two numbers. But here's the thing. When I have an even amount of numbers, this is exactly half the list. There's 8 numbers before this and 8 numbers after this. Sorry for that arrow. So sure, the median is the average of those two numbers, which is still 63. And what's funny about this is quartile 1 and quartile 3 would be exactly the same, wouldn't it? Because I don't exclude those two numbers I needed to find the median. I don't know if I said mean before. I meant median. I don't cross off any numbers, and now I find the median of the first half of the list, median of the second half of the list. That's Q1 and Q3 respectively. Okay, over explanation. And this is now what a box and whisker plot. How many people recognize this? Raise your hand. No? Okay, so here's your job, though. Your job is to make a scale out of this. So what you should do before you do this, because you can do this on a graphing calculator as well. They do have that skill to do that, but it takes twice as long than doing this by hand. You got to put a scale down there. So you need a number line with an appropriate scale identified going by tens, making sure you have nice equal distances. And then you graph these things on a number line right above. So the first thing that you have is the minimum. The minimum that we have is 21. That's called a whisker. This is why they call these box and whisker plots. Okay? And that's at 24-ish. And then Q1 was at 56. So this is quite a long whisker. As a matter of fact, we'd probably find out that this 24, if this was grades on a test, that's probably an outlier. All right? And then from Q1 to the median's at 63. So look, that's a smaller box than the distance from median to quartile 3. All right? Which is at 79.5, close to 80. Then quartile 3 to the max, 93. Here's 25% of the data. Here's 50% of it. Here's 75% of it. Here's the last 25% of it. They're all 25% of the data grouped together. All right. I guess in a nice perfect scenario, this whisker would be equal to this whisker, which would be equal to this distance, which would be equal to this distance between those. So it just shows you some more about the data, where the 25% of each part is and how much of a spread it is in each of those, I guess. But anyway, one more thing, interquartile range. Can everyone say interquartile range? Take Q3 minus Q1, get an answer. Whoops, that's a wrong press.